family. After this training,哪里？इशू है सर कुछ और चल रहा है कॉलेज डिस्कस करें वो दिया आपने
Good morning. Good morning, everyone. Welcome back to the training program. Today, according to the training schedule, today we're gonna introduce the minutes. The main content is the introduction of the core failures and the minutes. So we are honored to invite the expert and senior engineer of Mr. So Young from the project management center of Solar Steam Turbine. So without further ado, we would like to start now.
Thank you. Yes.就开始今天的这个培训内容。我们今天的一个培训内容主要是驱动机的常见故障以及这个检修的一个介绍。首先，我们介绍一下东方汽轮机源公司的一个企业宗旨。东方汽轮机源公司是以绿色动力驱动未来的企业宗旨，积极开展技术创新，不断推出新产品满足市场需求。目前产品涉及火电、核电、气电等发电领域，产品遍布多个地区和服务。
Yes, we would like to start with the DTC's tenet. As you know, with the enterprise tenet of green power driving the future, Dongfang Steam Turbine actively carries out the technological innovation and constantly introduce new products to meet market demand. At present, the products involve thermal power, nuclear power, gas power, other power generation fields, and the products all over many regions and countries.
我们先介绍一下公司的主要产品。核电的产品有100万等级半数转速核电的一个驱轮机，以台山核电1570兆瓦为世界单机容量最大的机组。火电有冷凝、空冷、供热等多种机型的或组合的完整产品体系，机组功率和参数从50兆瓦等级高压驱轮机到1000兆瓦等级的超临界驱轮机。燃机系列产品包括 G207A、G312A、G114A 系列， 7级包括 D100B、D100E、D78B 系列，活跃透频、对式风吸尘机以及0.5到50瓦各类吸尘机。
Yeah, we would like to introduce the main steam turbine products of Dongfang Turbine. First, the nuclear power steam turbine. In our company, we have the 1000 megawatt class, the half-speed nuclear power steam turbine. We take this example. The Taishan nuclear power steam turbine with the output of 1,715 megawatts, which is the largest capacity unit capacity in the world. The thermal power steam turbine. We have the condensing, air cooling, and heat supply and other types of the products. Also, we have this combination, and this type of combination, these products. The power and parameters, the region from the 15 megawatts grade turbine to 1000 megawatts grade after the supercritical steam turbine. In the gas turbine field, we have the gas turbine like the series with G270A and G312, G104 series with and also we have the GTCC. GTCC, the combined cycle gas turbine, that's combined with the steam turbine with D100B and D100B, D78B series of the steam turbine. Also, we have the industrial turbines like the feed water pump steam turbine, and with the output, the range of 0.5 to 50 megawatts steam turbine.
这张图所展示的是我们的火力发电厂的一个工作流程。
This picture shows the whole working process of in the coal-fired power plants.
这张照片所展示的是火力发电机组的一个厂房。
In this slide, there are two pictures which show the layout of the steam turbine building.
基本上，这照片所展示的是我的集中控制室，就是完成对吸尘机的一个运行控制的一个集中的办公室的一个展示照片。
This picture shows the centralized control room. In this place, we can complete the control of the steam turbine operation.
这张图片展示的是东方亚领界300兆瓦吸尘机高中压合钢2缸2排气的一个机组结构照片。
This picture shows the Dongfang subcritical 300 megawatt steam turbine, which is the an HP and IP combined cylinder, and it is 2 cylinders, 2 exhausts.
下面所展示的是东方超临界600兆瓦吸尘机高中压合钢3缸4排气的一个照片。
Now this picture shows the Dongfang supercritical 600 megawatt steam turbine, which is the HP IP combined cylinder and 3 cylinders and 4 exhausts.
以及东方超临界660兆瓦吸尘机高中压分缸4缸4排气的一个结构展示。
This is a structure picture of Dongfang Ultra Supercritical 660 megawatt steam turbine, which is the HP IP split cylinder, the 4 cylinder and 4 exhaust.
以及东方最新的超临界660兆瓦汽轮机高中压分缸4缸4排气的一个3维模型。
Okay, this picture shows the ultra supercritical 660 megawatt steam turbine, which is the HP and IP split cylinder, 4 cylinders, 4 exhaust. And that is the 3D model.
以及1000兆瓦汽轮机高中压分缸的4缸4排气的一个机型的一个展示图。
This picture shows the Dongfang Ultra Supercritical 1000 megawatt steam turbine. And this is a HP IP split cylinder, 4 cylinder and 4 exhaust type.
好，做完上述的机型展示后，正式开始我们今天第一个内容，一个典型的故障及处理的一个案例分析。
That's all for the product introduction. Now we would like to begin with the introduction of the typical failure and the treatment of a steam turbine.
我们的故障案例主要分为4个部分。第一个部分，计算机本体，包括以下3个小点：第一，轴承瓦温的一个高的一个案例，排放吊架未解锁的一个案例，以及导油缓气碳的一个案例。
Yes, there are 4 typical failures we would like to introduce. The first one is about the steam turbine main body, and these subjects they are 3 minor case we would like to introduce. The first one is the case of the high temperature of the bearing pad. Second is the case of a breaker unlocking. And the third one is the case of deposit on the oil deflector.
第二个部分为润滑油系统，包括2个案例，为断油烧瓦案例及润滑油突降故障案例。
The second typical failure is about the lubricating oil system, and there are also 2 cases we would like to introduce. First one is the case of oil cut off and the hand burning. The second is the failure case of the sudden drop in the lubricating oil pressure.
第3个部分是我们的自密封系统，我们举一个忘记手封送气造成转子弯曲的一个案例。
The third typical failure is about the self-sealing system. Yeah, there is one case we would like to introduce. That's the rotor bending case, which was caused by forgetting to check the glass seal steam delivery.
第4个部分作为输水系统，举一个输水系统不畅引起机组气缸变形和振动的一个案例。
The fourth typical failure is about the drainage system. There is one case, in the case of the deformation and vibration of the steam turbine cylinder caused by the poor drainage.
通过以上案例的讲解，我们向现场的用户传输一种解决问题的一种方法和思路。
And by the introduction of these 4 typical failure, we would like to give our end user kind of on-site troubleshooting and 就是现场解决故障的一种。Okay. Yeah, we would like to give the end user the kind of the DTC's thought about the troubleshooting on site.
我们开始第一个案例的讲解，轴承瓦温高的一个案例。
Yeah,
let's begin with the first case, which is the high temperature case of the bearing pad.
故障的现象为供电厂1号机330瓦亚令件，2013年12月大修后，1瓦的瓦温从87度逐渐爬升，到2014年8月已升高至98度，最高达到104度。
This typical failure occurs in a certain power plant. There is this steam turbine, which is the subcritical, and the output is 330 megawatt. This type of the steam turbine, after the overhaul of this unit in December 2013, the temperature of number one bearing. The temperature of the number one bearing pad gradually increased from 87 Celsius to 98 Celsius in August 2014, and the highest temperature was 104 Celsius.
以下是为它的一个故障特征。第一点，2013年12月到2014年8月两次停机过程中，1瓦的左右瓦温平稳下降，没有突跳的一个现象。
The failure features are as follows. During the two times of shutdown from December 2013 to August 2014, the temperature of number one bearing pad decreased smoothly without a sudden drop.
第二个现象为1瓦的瓦温左右两侧同时偏高。
Hello.
Yes.
Yes. You said the temperature of about 1 degrees is possible without sudden jump. This one I don't understand.
说的是一瓦瓦，就是没有突降，没有突降是什么意思？
就是在它们的运行曲线上没有呈现一个突然上升的一个趋势。
没有，不是平滑下降，不是。
不是这样。
Sorry, I must be the wrong translation. The temperature is decreased smoothly without a sudden jump, not drop. Sorry. Is that okay?
Oh, this one is number one bearing.
Yes, number one bearing pad.
Which is tilting pad, yeah? Which type is tilting pad?
Yes, tilting pad. Okay. Okay, we will continue. The temperature of the 1号轴承的瓦右两边。Okay. The second features of this failure is that the number one bearing pads there are two temperature measuring ports. Respectively, it is on the left side and the right side. And we found that the temperature measured from the both sides are synchronously increased.
第三个故障特征是运行时中环油模管压力为0.1兆帕，满足我们的设计要求0.078到0.098兆。
世界的 Yeah. During the operation, the oil pressure of the lubricating oil main pipe is zero point 0.1 megapascal, which can meet the design value range, which is close to the 0.0981 megapascal, and it can meet the design requirements.
第四个特征为1号头灯箱遮风面的温度为61.5度。
And the temperature of the split face in the number one bearing housing is 61.5 Celsius.
以及第5个最重要的特征，启动交流油泵回转后，1瓦的瓦温迅速降至87度，轮排油母管压力由0.1兆帕上升至0.1143兆帕。当停止交流油泵时，1瓦的瓦温迅速得到了一个恢复。
The number 4 feature is the most important feature for this typical failure. When the AC loop oil pump was started, a temperature of number one bearing pad, the temperature dropped to 87 Celsius. And the oil pressure of the oil main pipe increased from 0.1 megapascal to 0.143 megapascal. When the AC loop oil pump was stopped, the number one bearing pad recovered quickly.
以及第6个特征点，1瓦的瓦温不随机组的负荷而变化。
And the temperature of number one bearing pad does not change with the unit load.
那么这幅图所展示的是我们计算机停机过程中1、2瓦的一个瓦温的一个趋势图。从图中我们可以看出，随着这个转速的下降，轴承的一个温度也随之下降，瓦温并没有出现这个突然升高的一个趋势。
This picture shows the temperature curve of number one and number two bearing pads during the turbine shutdown. It can be seen from the picture that the bearing pad temperature decreases with the along with the decrease rotating speed decreasing, and there is no sudden increase trend of the pad temperature.
下幅图所展示的我们运行截图为这条曲线为我们的负荷曲线，可以看出随着我们负荷的一个变化，我们1瓦的左右两侧的瓦温并没有随之有很大的一个大幅的一个波动。这条平滑的直线为交流油泵的一个电流曲线，可以看出当交流油泵的这个启动以后，
觉得可能是用一条线数，先指出我指出一条线 B， 我指一下那个负荷曲线。
对。
In this picture, this is the load curve, and we can see that with the change of the load, the bearing pad temperature does not fluctuate greatly.
当我们的交流油泵启动后，我们也可以看到这条电流曲线，我们的1瓦左右瓦温迅速得到了一个下降趋势。
This line is the current of AC loop oil pump. We can see that the pad temperature decreased significantly after the AC loop oil pump is started. Yes, the red line and the purple line. Oh, yes, these two lines, two curves, the temperature of number one bearing pad. So when we start the lube oil pump, yeah, these we can see the difference compared to the left side and the right side. The temperature decreased significantly.
针对以上故障进行的一个原因分析，主要有以下5个点。第一点，行进过程中瓦温没有脱跳，排除了低速粘瓦的可能，但不排除就是瓦块的一个高速磨损。
Since the features, we have the course or analysis or the reason analysis. There is no sudden temperature jump during the shutdown process. We can eliminate them. The no speed rubbing, but cannot eliminate the high speed wear of the pad.
第二个点为左右两侧的瓦温同时升高，可以排除车轮岩元件损坏的一个问题。
And we can see because the temperature that we measured from the left side and the right side increased at the same time, so the damage of the temperature measuring elements is can be ruled out.
第三个点为轴承箱温度正常，排除了气缸热刻对这个瓦温的一个影响。
And the temperature of the bearing housing or bearing box is normal, so we can eliminate the heat radiation, the cylinder on the temperature of the bearing pad.
第四点，瓦温与基础负荷无关，就小修后这个初期的瓦温正常，可以排除轴系分配对我们瓦温的一个影响，以及这个轴瓦的一个安装问题。
And the temperature of the pad will not change with the unit load. So and the bearing pad temperature is normal at the initial stage of minor repair. So the influence of the shaft load distribution on the bearing temperature and the column of bearing installation can be ruled out.
第5个点，润滑油模管的压力正常，启动交流泵后瓦温骤降，初步判断可能是因为润滑油模管至1瓦供油管路上存在这个泄漏或者堵塞，造成了1瓦的供油不足。
The oil pressure of the main lube oil pipe is normal. After starting the AC oil pump, the pad temperature drops suddenly, so it is preliminary judged that the possible reason is the oil supply pipe from the main lube oil pipe to the number one bearing pad is leaking or blocking, which can result in the insufficient oil supply to number one bearing pad.
然后是我们的一个检查及处理过程。第一点，我们检查了1号轴承箱进油滤网是否堵塞，结果为没有发现堵塞。
Yeah, let's take a look at what we inspected and what the treatments. First, we check whether the oil inlet filter spring of number one bearing is blocked, and the result is no blockage.
从第2个检查点，我们发现了问题所在。检查前轴箱1号轴承进油管路时，我们发现1号轴承滑枕左侧的一个进油阀栏存在一个泄漏。
And we checked the oil supply pipeline of the front bearing box number one bearing. It is found that the oil inlet flange on the left side of number one bearing pad leaks.
在2014年8月的小修修时，我们对1号轴瓦轴承进油法兰垫片更换为巨石废弃垫片，将1号轴承进油孔由18毫米增大至20毫米，并对1瓦下半瓦块用白节抛光，去除了拉伤羽毛饰。
In the minor repair in August 2014, the gasket of oil inlet flange of number one bearing pad was replaced, and the oil inlet orifice of number one bearing was increased from 80 millimeters to 20 millimeters. And the lower half of number one bearing pad was polished with the cleaning cloth to remove the stray burr.
通过上述处理，在2014年9月剔除小修后，机组带满负荷，成功稳定运行，1瓦的瓦温稳定在了87度。
After the treatment in September 2014, the unit was restarted after and operated stably with load, and the temperature of number one bearing pad was stable at 78 Celsius.
那张图片所展示的，就是我们从现场发现了这个润滑油从这个轴承的进油法兰处存在一个泄漏线现象。
This picture shows that the lube oil leaks from the flange, not from here, the flange.
导致轴承瓦温升高的原因很多，供油不足是只其中的一个原因，还可能有的原因为轴承的标高的影响、润滑油清洁度的影响、轴线表面粗糙度的一个影响，以及轴承顶系及接触的一个影响，可清瓦瓦块是否能摆动的一个影响，转转中心的影响。供油不足的原因可能有油管的泄漏，就是刚才我们案例中所提及到的，还有就是管道的一个堵塞，比如进油节流孔的法兰尺寸是否满足设计要求，管道中是否存在有异物的一个堵塞，检修时封堵油孔的纱布掉进了油管当中，冲洗时的临时滤网是否已经得到了一个拆除，要根据不同情况的一个具体情况进行分析。
There are many reasons for the temperature increase of the bearing pads, like the insufficient oil supply is one factor. There are also other possible reasons, like the influence of the bearing installation height, the cleanliness of the lube oil, the surface roughness of the shaft diameter, the top clearance, and the contact of bearing, the spring or which is the movement, the tilting path, the influence of the rotor center. The simple reasons for insufficient oil supply are oil pipe leakage. As mentioned in the test chapter before, there are just also pipeline blockage, such as whether the size of oil inlet throttle orifice meets the design requirements, whether there is foreign object blockage in the pipeline, the gauge blocking the oil hole falls into the oil pipeline during maintenance, and the temporary filter screen is not removed during the oil flushing. Specific analysis needs to be carried out according to different situations.
我们开始第二个案例的讲解。第二个案例为弹簧吊架未解锁的一个故障。
Next, we would like to introduce the typical failure of the spring hanger not unlocking.
它的故障现象为冷电场一号机组
Hello.
必须设瓦
Yes.
Yes. So, what problem is the temperature rise to 104 degrees Celsius? So this one happened only for the insufficient lube oil supply, yes, and the leakage.
Just a moment，抱歉，这个是就是那个这样子的很高，就是这个我们可以就是说是那个就是功能的不足，就是那个泄漏是这个样子。是是是，就是后来你没看过，是后面不止对，
会不会也就要考虑到底晒或者泄漏，然后我们可以然后再去找一个具体的泄漏点。
Yeah, the main reason for the insufficient oil supply and the main reason might be the blockage or the leakage. Yes, you're right.
Yeah, blockage and leakage. But in our plant, they are already installed the orifice for controlling the flow. But how can we understand that we need to increase the flow? That means orifice diameter is 18 diameter to 20 diameter they make as per previous problem. So if we find out the leakage, so why we change the orifice diameter?
Okay, just a moment. 这样这样，哎，那个什么直径增卡到20的呢？是你想测一下，对，或者怎么样去，对，
就是直接将那个原精油的一个回复，进行一个加工和大油就可以了，越来越那个，就成功了，很好。
Yes, let me confirm this. Sir, you asked how to realize this result. Increase the orifice diameter from 80 millimeter to 20 millimeter. Is that right?
Yes. Because we find out the problem that maybe the insufficient oil supply for the leakage. If leakage is okay, maybe we can use the gasket. If leakage is okay, so that time flow is okay. But why we cannot understand that we need to change the flow, we need to increase the orifice diameter. That's
And you asked how to increase this. Yeah.
no, how to increase is okay. This one no problem. But why we need to increase? Because we already find out the problem, no, that leakage. If we recover it, so the flow will be okay.
OK。既然我们已经找到这个就是原因故障了，为什么还要把这个简便从18、20呢？
因为我们的就是有时候根据现场的实际情况，它的设计指标会与就是实际的运行存在一个微量的一个偏差。我们增大这个作用其实是进一步来弥补1号的一个相当于规模量1号这么一个不变的。就是说做这个工作的目的是进一步保证1号的机器量不得到一个足够高。
但是它是在那个就是
一个水响范围。
这个范围是没有问题的。
这个范围中，它可以，如果现在有问题，这个范围的话，就可以跟我们进行咨询，就具体报。
实际肯定是满足要求的。
对。
Yes. Sir, Mr. Zhou explained like this. The time we do this step, we take care of this step just to further make sure that the oil supply is sufficient. And this we increase the diameter from 18 to 20 is qualified, and it can meet the technical specification. Just want to further make sure to realize the purpose of the sufficient oil supply.
Yeah, I understand. But if same kind of problem is happening in other bearing and we increase the orifice diameter, so that time the main head of lube oil pressure will be less. Yes. So how we can mitigate this problem? Suppose another three bearing also same kind of problem is happened and we increase the orifice diameter. So that time lube oil pressure will be less. Yes. So how we can mitigate this?
How to make this diameter to increase?
No. I'm saying same kind of problem is happening maybe the number 2 bearing, number 3 bearing, and we increase the inlet orifice diameter. So that time maybe the lube oil header pressure will be less. You get my point?
就是我们把它扩大一些，其他的影响。
只是为了增大一号的那个经济流量，
进补量，
确保的充足。
也是这种。
它是单位影响，是唯一好，指副手管是处理唯一好的，对它实际上是没有影响，所以我们增长的量非常小。就这个量是我们只是我们公司考虑范围。这个是上是吧？20号操作是没问题。因此这个就是增大1号，手背会强，然后还稍微其实这个这个量是我们设计考虑的一个范围。你如果出现这个问题，也可以也就是说在解决之前那个找到漏点之后处理之后，就能满足要求的话，也可以做这个事情。
但是北京科技公司收的这个费用会不会让那个会影响这些？
也是做在他们量变低，跟我们是一点好的。
Yeah, sir. And your concern is that if we increase the diameter, is that will it influence the oil supply for number 2, 3, 4, and these bearing of the oil supply?
This one I am saying that if another bearing also have same problem.
If the number 2 number 2 bearing has the same problem.
Yes, and we increase the orifice diameter. So that time lube oil pressure will be less. Main header.
Could you please type the keywords?就是23号的总经理也是非常没有，就是我们所有的相当于把那个产品都灯卡，那这个的时候是那个那个润滑油压就会减少。所以相当于说这灯塔检查。
因为这个要就是可能我们没讲过，就是鱼灯的话，是否是一个增大或者增大多少，就是与我们制造厂就是保持一个那个沟通嘛，及一个咨询，就是根据每个去进行那种，就是根据。
Yeah, sir. Mr. Zhou just answered. We should subject to the specific situation of each bearing. If there might teeny tiny possibility of this of these bearing happens the same failure. So we may according to the specific situation, then we will figure out the corresponding treatment.
Okay. Because why I am asking that we solve the leakage problem, and
Yeah.
that means flow will be sufficient as per your design. But if we
Yeah.
increase the orifice diameter, so that time loop oil main pressure will be less, and then other bearings we maybe the oil supply not sufficient. So that's why I was
Yeah.
that in which basis,
Yeah,
in which basis, yeah, in which basis we are saying that we need to increase the oil flow. So that's okay. Okay, thank you.
Okay.
那我们就开始继续讲解我们第二个案例，一个弹簧吊架未接手的一个故障。这个故障现象为某电厂1号机组1000兆瓦烧伤连接机组2014年7月投运，2016年12月失修后，反复的运行巡检时发现 A、B 高桥门流动机支架与阀门连续螺栓全部断裂，流动器支架与阀门已经完全脱开，高桥门的流动机发生了倾斜，与高桥门连接的流动机的H 管道发生了一个变形。
Here is another typical failure, which is the spring hanger unlocking. A certain power plant, there is a 1000 megawatt output supercritical in Turbine, and it was put into operation in July 2014. So the seat repair in December 2016, when the unit was started as a full load. During the inspection, found that the connecting bolt between the A and B SD control valve, I dropped the the control valve actuator bracket and the valve were all broken. The actuator bracket and the valve were completed, created. The HP control valve actuator was deflected. And the oil pipe connected with the control valve actuator was default.
这个原因分析为，经检查发现，高强尾动机支架相连的弹簧吊架未进行一个解锁，热态时高强门的较冷态向下膨胀约4-5个毫米，由于弹簧吊架未进行一个解锁，热态的高强门由动机支架与阀门的连接螺栓承受了很大的一个间接力，阀门的状态进行了一个交替，该螺栓到达了疲劳极限后，最终全部被进行了一个剪断。
After our inspection, it is found that the spring handler connected to the actuator support of HP control valve was not unlocked. When the valve is hot, it will expand about 15 millimeters downward than when it is cold. Because the spring handler is not unlocked, the connecting bolts between the actuator bracket and the valve will bear the greatest shear force when it is hot. The valve will change when it is cold and hot, and all the bolts will be broken when they reach the fatigue limit.
它的故障处理为对高成本发动座与永动机采取了临时措施，坚持运行1周后，机组进行了一个停机，更换全部断裂的螺栓，将弹簧吊架复合转换后进行一个解锁，并将弹簧一个行程按温态调整，热态时再按明牌的指示进行一个整定。
The power plant took the temporary reinforcement measures for the at the high pressure control valve at the actuator. After 1 week of operation, the unit stopped, replaced the broken bolts, changed the load of the spring handler, and unlocked it. Adjusted the spring control according to the temperature state, and then set the work thing. And adjust it according to the warm state and set it according to the instructions on the nameplate in the hot state.
现在我们的一个防范措施为，因为是我们的新建项目技术整套启动前，对所有的波形膨胀节、弹簧吊架是否进行解锁进行一个确认，并妥善保管我们的解锁装置，以备检修时使用。做后续对波形膨胀节、弹簧吊进行更换，也应严格按照厂家图纸进行一个吊装和解锁。
Before starting the whole set of the new project and unit, check and confirm whether all the battle expansion tools and the spring handler are unlocked, and properly set the unlocking device for minutes. If the battle expansion tools and the spring handler are replaced later, the lifting and the unlocking shall be carried out in strict accordance with the requirements of the manufacturer's drawing.
从第一张图片可以看出，我们的一个永动机空中座已经出现了一个明显的一个倾斜， 从第二张图片检查后发现，我们的油动机充座与阀门的连接螺栓全部是一个断裂的状态。
On this slide, we can see that the actuator has obviously inclination. After shutdown, it found that all the connecting bolts on the right side between the valve, between the actuator and port at the valve are all broken.
左边的这张图所展示的是为油动机支架阀门的一个连接示意图。
On the left side, this picture shows that the schematic diagram of the connecting between the actuator support at the valve.
作为支架与阀门连接螺栓的一个安装位置。
Here is the installation place for the spring handle and the connecting bolt.
作为弹簧吊架的一个安装位置。
This place is the spring handle installation place.
右边这张图片所展示的是弹簧吊架未进行解锁的一个状态。
And the picture on the right side shows that the spring handle is not unlocked.
弹簧吊架未进行解锁，使得整个支架呈现一个刚性，阀门的一个热态交替变化，使螺栓受到很大的一个剪接力，最终导致了我们的一个连接螺栓的一个断裂。
This because the spring handle is not unlocked, that makes the whole support rigid. The cold and the hot state of the valve change alternately, and the connecting bolts are subject to the additional shear force, which can eventually lead to the bolt fracture.
第三张图片所展示的是我们弹簧吊架需要解锁的一个零件。
This picture shows that all the parts needing for the spring handle unlock.
需要将这4个零件全部拆除后完成一个解锁。
And we need to remove all the poor parts and unlock the spring handle.
右边这张图片所展示的是弹簧吊架的一个形成的一个指示图，弹簧吊架负荷完成进行解锁，并将弹簧吊架按形成指示进行一个调整。这里的红色代表的是一个耗时热态，蓝色代表一个冷态。
The picture on the right side is the indication diagram of the spring handle. The spring handle is unlocked after load conversion, and the spring stroke is adjusted according to the instructions. The red edge represents hot state, and the blue C represents cool state.
安装时需要对系统中的弹簧吊架波形膨胀节进行一个解锁，避免机组运行后出现故障。
During the installation, it is necessary to unlock the spring handle. And the below in all systems to avoid the failure after the unit operation.
好，我们开始第3个案例。第3个案例。
Third case is about the carbon deposit layer of the oil deflector.
它的构成现象为电厂3台660兆瓦机组， 2017年6月至9月分别投运，2017年11月获得的反馈，三台机组的2号、3号、4号轴承出现了一个周期性的。
3 units of the power plants. They were put into operation from June to September and 2017, and their and the bearing shaft vibration of number 2, number 3, and number 4. Where's that? 三台阶。Number 2, number 3, and number 4 bearings of the 3 units all occurred failure of periodic fluctuation vibration. And these failures were feedback in November in 2017.
它的一个故障特征为第一点路的幅值都大，但呈现了一个周期性的一个波动。
The features as the amplitude of vibration is small, but it presents a periodic fluctuation.
第二个特点为这种在机组调期间均未出现，在运行一段时间后出现该问题。
This vibration failure did not appear during the unit's commissioning, but appeared after a period of operation.
我们的检查情况为停机揭开轴承箱盖，对油打环进行检查，发现了油打环严重。
And we did some inspection after the shutdown. Lifted the bearing housing cover, checked the oil deflector. It was found that the oil deflector has serious carbon deposits.
我们油打环积碳形成的一个条件为有3个特征：第一是高温，第2个是杂质，第3个是润滑油。
There might be 3 factors for the carbon deposition in oil deflector. First is the high temperature, the second is impurity, and third is the lubricating oil.
这张图片所展示的就是我们2号、3号、4号轴承呈现的一个周期性波动的一个曲线。
This picture shows that the number 2, number 3, and number 4 bearings, the vibration curve with the periodic fluctuation.
左侧这张图片是油打环上一个积碳的现象。
The left picture as the carbon deposition accumulated in the oil deflector.
这张图片与轴颈的一个碰磨导致振动出现一个周期性的一个波动。
On the right side, the picture shows that as the damage caused by the 轴颈是吧？the 轴颈Oh, yeah. The right side picture is the damage caused by the carbon ring to the shaft diameter. Due to the collision between the carbon ring and the shaft diameter, the vibration fluctuates periodically.
油打环属于某些原因积累了一些积碳，与油混合后成为一个有油泥，在高温作用下碳化形成了积碳，并且越积越多，最终与卵子发生了一个碰磨。
Due to some reasons, some impurities accumulated at the oil deflector, which become the oil sludge after mixing with the oil. Carbonize under the action of the high temperature to form the carbon deposits and accumulate more and more, and finally collide with the rotor.
有氧含积碳多发生在高中压分缸机组的高压进气、中压进气端这两个位置运行时，温度才能满足高温的要求。同时，这个档附近的保温层的安装需要可靠，避免保温棉进入油大。部分电厂在试运期间，厂房还在施工，密度较差，也容易导致灰尘进入油档，形成积碳。这两个方面需要引起重视。油档含积碳隐患机组也可以考虑换新型的一个空气油档，在油档环中注入压缩空气，避免杂质进入油档，来避免这个油档环的一个积碳。
The carbon deposition of the oil deflector mostly occurs at the high pressure steam inlet and the intermediate pressure steam inlet ends of the temperature at these two positions can meet the requirements. At these two positions, there might be there are the high temperature and
দাদা আমি আপনাকে হোয়াটসঅ্যাপে দিচ্ছি
the installation of the insulation layer near the oil deflector needs to be reliable to prevent the installation cotton from entering the oil deflector. So some power plants are still under construction during the trial test, trial run with poor cleanliness, which is also easy to cause the dust to enter the oil baffle deflector and form the carbon deposition. These two reasons need to be paid attention to. For the units with hidden danger of carbon deposition in the oil deflector, a new type of air oil deflector can also be considered to be replaced. Compressed air is introduced into the oil deflector to avoid the impurities entering the oil deflector to avoid carbon deposition in the oil deflector.
好，我们开始第二个部分的第一个案例，断油烧网的一个案例。
Now let's talk about the failure happened as a lube oil system.
首先，它的一个故障过程的一个展示是这样的：某电厂2号机2017年11月25日1.45英电网故障，机组甩脱和跳机。降速过程中，交流油泵按照逻辑响应瞬间断电，直流油泵未按照逻辑要求进行连起，转速降至1200转时，各瓦温开始升高，在1:52分到达0时，轴承最高温度到达了174度。后直流油泵启动后成功恢复供油，从跳机到恢复供油共20分钟，转子舵走了7分钟。供油恢复后，盘丝不能投入。2:09分关闭所有输气阀，开始焖缸。11月27日8:38逐渐恢复盘车，电流30 2.5安；11月29日12点，电流恢复27.5安。
Hello.
Yeah. Yes.
Yeah. So for the carbon deposit, what is the treatment you say?
Sorry, the last two words I missed. Could you please repeat?
For the carbon deposit fault, what is the solution? How we can simulate this fault?
What's the solution for the carbon
Yeah.
deposition? Right.
Yeah.
Okay.
How we can simulate it?
一般我不能去控制它的温度，但是可以清洁这边的钢。今天这份放进去，就是比较样子，给比如说换细的
就是不是做清洁做？
对，凹这样会有核心。
这些律法说是他开始不需要
啊，这些清理鸡蛋就是
在清
就是
不擦。
就是用我们需要对它的对它的做浏览或者进行一个剥离，就是绿色，灯光就特别，或者就直接割吧，然后有我觉得是可以用掌握工具吧，进行一个对除。
常规工具还是特殊工具？Yeah, sir, I would like to answer you for the question about the solution of the carbon deposit. When the carbon deposition occurs, we need to remove the carbon deposition layer by the commonly used tools and remove this deposition. Yes. If this
Okay, we can remove the carbon deposit, but I want to know what is the prevention that before carbon deposit, what type of process we need to do?
Okay, the prevention. Okay.
Yeah.
Yeah, we should pay attention to the cleanliness first, especially the um, the the building is under construction and other factors may affect the cleanliness. The second, we just mentioned a new type of this oil deflector is the air oil deflector. We can replace that with this kind of oil deflector.
So in our plant, this type of oil deflector is available.
这个可以或者
我后期的身体比较恶劣，对，往下再弄。 行行的，平时正常的情况下就是这样。
They should pay attention to the cleanliness, and um, we usually clean that remove the impurity, just like this. And
Oh, it's fine.
yeah, there is no need to upgrade the
Oh.
No need to procure this new type.
No, not procure. If a donkey already provided for our friend, so maybe this problem can be mitigated. Okay, continue.
我们不去改变它。
就是如果不限制它不会怎么样。Yeah, we don't pay much attention to the varying temperature. It's not the factor. It is not necessary to be taken into consideration during the carbonization problem. Okay, we can ignore the varying temperature under such condition. Now we'll continue with the case of the oil cut off and the pad bearing. 怎么讲那个？Okay, that's 1:45 on November 25th, 2017. The unit 2 in the power plant tripped due to the power grid failure. During the speed reduction process, the AC loop oil pump was started according to the logic, and then the power was cut off instantly. The DC oil pump was not started according to the logic required. When the speed dropped to 1,200 RPM, the temperature of each bearing pad began to rise. When the speed reached 0, 152, the maximum bearing pad temperature reached 174 Celsius, and then the DC oil pump was started successfully to resume the oil supply. It took 20 minutes from tripping to oil supply recovery. The rotor coasting took lasted for 7 minutes. After oil supply recovery, the turning gear could not be put into operation. At 2:09, all drain valves were closed, and the cylinder remained in high pressure and closing state. At 20:38 on November 27th, the turning gear was gradually restored, and the current was 32.5 amp. At 12 o'clock on November 29th, the current was restored to 27.5 amp.
这一张那个转的曲线，机组从3000转到0转， 用了7分钟，期间各轴承瓦温进行升高，最高达到174度，已经超过了轴承允许的温度。轴承乌金烧毁。
This is the speed curve. When the unit speed is changed, is reduced from 3,000 RPM to 0. It took only 7 minutes. During this period, the temperature of each bearing rises, and the maximum temperature is 174 Celsius, which has exceeded the allowable temperature of the bearing, as the bearing is burned.
从停机开始20分钟后会恢复供油，供油恢复后，轴承瓦温无突降。
The oil supply was restored 20 minutes after the unit shut down, and the bearing pad temperature did not drop suddenly after the oil supply was restored.
这个故障的原因主要为机组跳气后连起交流油泵，由于电网故障不供电，柴油发电机连起，但由于某些原因启动后瞬间就跳机了。不如中排油泵连起后瞬间断电，后直流油泵启动信号发出后，但运行人员将直流油泵的运行方式切换到了就地方式，因此没有实现连手启动，最终导致了事故的发生。
After the unit trip, the AC lube oil pump was started up. Due to the power grid failure, the system had no power supply, and the diesel generator was started up. However, due to some reasons, the unit tripped immediately after starting, so the lube oil pump was cut off immediately after starting. After that, the start signal of DC emergency oil pump was sent out, but the operator switched the start mode of DC emergency oil pump to local mode, so the interlock start was not realized. It eventually led to the accident.
后续的那个故障处理为各轴承发现钨金损伤严重，特别是1和2号的轴承最为严重，分离轴承轻微损伤，转子轴颈存在不同程度的一个拉伤痕迹。低压模块各轴峰块这个磨损比较严重。
The tungsten metal of each bearing is seriously damaged, especially the number 1 and number 2 bearings. The thrust bearing is slightly roughed. The rotor has different degree of scratch marks, and the steam seal blocks of low pressure module are seriously worn.
除更换抽气轴承以外的转子进行了转子的修复，
ভালো
更换
লাগছে
了损伤的一个气动圈。
Replace and the troubleshooting is also includes the replacing all bearings except the thrust bearing, and repairing the rotor, replacing the serious damaged steam seal ring.
在机组异常的情况下，如果盘车不能投入的话，通常采用这个焖缸的方式来防止冷气进入我们的汽轮机，避免转子发生一个弯曲的现象。焖缸的具体措施如下：关闭各段收气管道的一个隔离阀和输水阀，停止轴封供气，在各气缸轴封或气缸上的漏气处用保温棉进行一个封堵。焖缸停1个小时后，间隔1个小时启动一次盘车，或适当用手动盘车一下，直到能够投入我们的盘车。当烧瓦发生后，不要立刻恢复顶轴油， 轴径和轴承摩擦后仍处于高温时，突然进油会造成轴径的一个开裂或者裂纹的一个扩大。
The turning gear cannot be put into operation under abnormal conditions of the units. The method of closing the cylinder is usually used to prevent the cold air from entering the steam turbine and avoid the bending of the rotor. The measures for cylinder sealing are as follows. Close the isolation valve and the drain valve of each section of the steam extraction pipe. Stop the steam supply of stop the steam supply of gland seal and block the steam leakage on each cylinder. Gland seal or cylinder with thermal insulation cotton. After the cylinder is blocked, start the turning once every 1 hour, or manually turn once moderately until the turning gear can be put into operation. Do not restore the jacking oil immediately after the oil cut off and pad burning. Pad burning when the shaft when the shaft journal is still at high temperature after friction with the bearing. Sudden oil inlet is easy to cause the shaft cracking or the crack expansion.
这两张图片向我们展示的就是我们的一个轴瓦的一个钨金烧毁的一个情况。
These two pictures showed us the tungsten burning of the shaft.
这张图片是我们的一个推力瓦一个磨损的一个情况。
This picture shows the thrust bearing pad was worn.
第三张图片是我们的一个转子的一个轴颈受到了一个损伤的一个情况。
This picture shows the shaft. The journal was damaged.
这里是轴承上被挤压出的一个这个钨金的一个残片。
This is the tungsten sheet that was squeezed from the by the bearing. So from the bearing.
断油烧瓦的后果是比较严重的，在国内发生过某电厂断油烧瓦，由于气风雨叶片发生严重碰磨，甚至更换了那个转子上的部分叶片，在有叶片的飞溅情况下，可能就长到了2个月，间接的电那个工期的只是无法的，国外的电厂需要提前。
The series due to the serious collision between the steam seal and the blade. So blades on the rotor have been replaced in domestic power plants with the blades spare parts. The repair cycle is as long as 2 months, resulting in direct repair economic loss of 40 million RMB, and the indirect loss of electricity power, construction period, and other losses cannot be estimated. Therefore, we suggest that the power plants, especially foreign power plants, need to prepare relevant spare parts in advance to reduce the accident losses.
好，我们进行润滑油部分第二个案例讲解，润滑油压突降的一个事故。
The second failure case happened in the lube oil system.
它的故障现象为某电厂1号机组135兆瓦的一个超高压，2015年4月试运行期间，超速实验后，润滑油模管压力由0.17兆帕突降至0.14兆帕，72小时试运时机组带125兆瓦的负荷，润滑油模管油压从0.13兆帕突降至0.115兆帕，连起了这个交流油泵，润滑油模管压力上升至0.19兆帕，稳定后，现场试着关闭交流油泵，润滑油模管重新下降到0.15兆帕，并再次连起了这交流油泵。此后，这个交流油泵需一直进行一个陪转。
During the test run operation of one unit, which is the ultra high pressure, with the output of 135 megawatt in a power plant in April 2015. After the overspeed test, the oil pressure of the lube oil main pipe suddenly dropped from 0.17 megapascal to 0.14 megapascal. During the 72-hour test run operation, the unit was loaded with 125 megawatt. The oil pressure of the lube oil main pipe suddenly dropped from 0.13 megapascal to 0.115 megapascal, and the oil pressure of the lube oil main pipe rose to 0.19 megapascal. After the situation is stable, they try to shut down the AC lube oil pump on site, and the oil pressure of the lube oil main pipe dropped to 0.115 megapascal again, and the AC lube oil pump was linked again. After that, the AC lube oil pump had to run along all the time.
它的故障特征为：第一点，首次整套启动时，油系统的各个参数均在设计要求范围内。
首次第一次启动吗？
第一次启动。
哦，for the first starting first time for the unit start, all the parameters of the whole set of the startup oil system should be within the design requirements.
第二个特点是，运行一段时间后，主油泵进出口油压和润滑油模管油压呈同步下降的一个趋势。
After running for a period of time, the inlet and outlet oil pressure of main oil pump and the oil pressure of lube oil main pipe decrease simultaneously and gradually.
第三个特点为，机组在超速实验和72小时考核试运期间出现了2次润滑油突降。
During the overspeed test and the 72-hour test run operation.
的油压在这个问题中，在这个现象中，让出的比较多。
In the turning condition, the oil pressure of the lube oil main pipe changes little before and after the sudden jump.
这张图的调试期间，第一次润滑油压有一个突降，润滑油压从0.17兆帕突然降至0.14兆帕。
This picture shows that during the test run, the lube oil pressure drops suddenly suddenly from 0.17 megapascal to 0.14 megapascal.
这张图这是72小时试运期间第二次这个油压突降，润滑油压从0.13兆帕突降至0。润滑油压从0.13兆帕突降至0.15兆帕，启动润滑油泵后，润滑油母管压力升至0.19兆帕。
This is the second sudden drop of the lube oil pressure during the 72-hour test run. The lube oil pressure suddenly dropped from 0.13 megapascal to 0.115 megapascal. After starting the AC lube oil pump, the pressure of the lube oil main pipe rose to 0.19 megapascal.
这张图的主要展示的是主油箱内的一个主油泵的一个出口管道，射油器经由母板法兰带油石棉垫片腐蚀的一个情况。
This picture shows that the outlet pipe of the main oil pump in the main oil tank at the plunging plate flange of the oil inlet main pipe of the oil ejector are corroded and damaged.
图中这个位置表示的是这个法兰的垫片已经丢失，导致了我们这个石油气的一个供油不足，造成了我们这个油压的一个突降。
This error shows that the flange at this position is lost, which leads to the insufficient oil supply of the oil ejector and the sudden drop of the oil pressure.
我们的这个原因分析为：第一点，首次整套启动的润滑油压系统和参数均在设计范围内，初步排除了这个系统设计的一个制造问题。
First, we analyze the reason for this failure. All the parameters of the whole set of a startup lube oil system are all within the design range, and so we can eliminate the design and the manufacturing reason of this system.
第二个特点，根据我们盘的状态，润滑油压母管的油压能恢复到突降前，初步排除了这个润滑油供油的管道的一个泄漏的一个问题。
And in the turning state, the oil pressure of the main lube oil pipe can return to the level before the sudden drop, and so the leakage of the lube oil supply pipe can be eliminated.
第3个点为定速3000转运行一段时间后，主油泵进出口油压和润滑油补管的油压同步逐渐下降并2次突降，判断主油泵进出口的管道堵塞泄漏的可能性比较大，导致了我们主油泵的一个出力不足，造成了一个主油泵出口油压的一个小下降。
After running for at a constant speed of 3,000 RPM for a while, the oil pressure at the inlet and outlet of the main oil pump as the oil pressure of the lube oil main pipe decreased gradually and suddenly, and chronologically twice. It was judged that the possibility of blockage and leakage of the inlet and outlet pipes of the main oil pump was large, which led to the insufficient output of the main oil pump and the decrease of the oil pressure at the outlet pipe of the main oil pump.
我们的处理措施为72小时基础消缺期间，导油检查主油箱内部的所有的这个法兰垫片以及胶质滤油泵的出口的一个立体槽的安装方向，发现这个主油箱内射油器进油模板法兰垫片的耐油石棉垫片同时损坏，此处即为这个主油泵出口的管道一大漏点，我们更换了垫片。
During the 72 hours in the unit deflect elimination period, the we inspect all the flange gaskets inside the main oil tank and the installation direction of the check valve at the outlet of AC/DC oil pump. It was found that the oil-resistant asbestos rubber plate gasket under the flange of the main oil injector inlet main pipe in the main oil tank was corroded and damaged. That's the big leakage point in the outlet pipe of the main oil pump. So we replaced the gasket.
这个机组完成消缺后启动，定速3000转。我们停断了交流油泵，花油模管的油压稳定在0.19兆帕，主油泵出口的油压稳在了2个兆帕。此后运行再未发现过这个油压突降的一个情
况。And the unit was restarted after the eliminating the defect. The constant speed was 3,000 RPM. The AC lube oil pump was stopped, and the oil pressure of the lube oil main pipe was stable at 0.19 megapascal, and the oil pressure at the outlet of the main oil pump was stable at 2 megapascal. Since then, no sudden drop of oil pressure had happened.
在安装及长期运行后进行检修时，应对我们这个油系统的各个法兰垫片进行检查，必要时进行更换。特别是因为我们的国外项目由于运输时间长，从生产制造到现场的安装时间间隔长，部分垫片可能出现软化、腐蚀等现象，导致密封失效。试运后，此类故障查找原因比较困难，处理也比较繁琐，建议要提前进行一个预防。
During the installation and maintenance after long-term operation, each flange gasket in the oil system shall be inspected and replaced if necessary, especially for foreign projects. Due to the long transportation time and the long time interval from production to on-site installation, some gaskets may have agent corrosion and other phenomena result in seal finish. After the tester run operation, it is difficult to find the cause of such failure and the treatments and the treatment is complicated, and it is recommended to make some prevention in advance.
那我们看是第3个系统的第一个案例，就是忘记轴控供气造成转子弯曲的一个案例。电它几乎做以后，相应上首先电能源发入啊。
The another failure is the rotor bending, which was caused by the shaft seal steam supply.
这个故障现象为某电厂的2号机组300兆瓦的一个压连接机组，2003年7月热赛启动前，忘记向轴控送气约30分钟，发现机组负重差增大，立即给轴控送气。第一次冲转，获得器左侧温度为307.4度，右侧为350.4度。高中压内缸上半外壁温度为338，机组转速升至1138转时，发现2x 轴震达到了190秒，2瓦的轴震达到了70秒，转速上升至1308转时，振动保护跳机。降速过程中因振动上升，立即破坏了真空紧急停机。此后再次进行了4次冲转，并在中压转子上加平衡块499克，均不能解决机组的振动问题。
There is a steam turbine of subcritical and with the output of 300 megawatt in a power plant. Before the hot startup in July 2003, the operator forgot to send the steam to the plant seal for 30 minutes. When they realized this situation, that the negative differential expansion of the unit increased. They immediately sent the steam to the plant seal. During the first rolling, the temperature on the left side of the superheater is 307.43 Celsius. The temperature on the right side is 350.4 Celsius. The temperature on the outer or of the upper half of the HIP inner cylinder is 338.21 Celsius, and the unit speed rose to 1,138 RPM. It is found that the vibration of 2 axes reached 190 micrometers, and that of number 2 bearing reached 70 micrometers. When the speed rose to 1,308 RPM, the vibration protection trips, and the vacuum is immediately destroyed due to the vibration rising during the deceleration. After that, the vibration of the unit cannot be solved by 4 times of rolling, and adding 499 grams balance block on the middle on the IP and LP rotor coupling. The vibration of the unit cannot be solved. This
这原因分析为经过与制造厂以及电力试验研究院的所有专业进行分析，判断我们的高中央转子发生了永久的弯曲。导致弯曲的原因如下：运行人员违规操作，在机组热态时起机时， 整风送气滞后于抽真风时间近30分钟，导致我们的冷气沿转子轴风踢出去，轮机转子受到局部冷却，是导致转子弯曲的直接原因。
After the discussion with the experts and the manufacturer, the electrical test institute, it's judged that the HIP rotor permanently bent. The causes of the rotor bending are as follows. The operation against the rules and the regulations. When the unit start up in hot state, the steam delivery from the nacelle is late for 30 minutes than the vacuum pumping time, which causes the cold air to enter the turbine along the shaft seal of the rotor. And the rotor is partially cooled, which is the for the rotor bending.
第二点是我们这个机组冲断的参数选择不合理，冲断时组成系统温度与热态开机的要求不符配，冲断的如果测307.43度，而高中压内缸的上段外壁温度为338度，启动时出现了一个负温差，是导致转子弯曲增大的一个重要原因。
The improper selection of the unit rolling starting parameter. The main steam temperature during the rolling does not meet the requirements of the hot startup state.
The main steam temperature on the left side is 307.43 Celsius, and on the right side is 315.4 Celsius, while the outer or temperature of the upper half of the HIP inner cylinder is 338.21 Celsius, and the negative temperature difference during the startup is an important reason for the increase of the rotor bending.
我的检查处理方式为开缸进行检查，发现高中压中间气泵齿局部出现了一个损伤，高压转子的弯曲达到了0.25毫米，2号轴承出现了轻微的损伤。对转子进行处理后，机组启动并运网成功，顺利站满复合。
And we did some inspection and carried out the treatments. During the cylinder opening inspection, it was found that the fins of HP and IP steam seal were slightly old. The HP and IP rotor was bent by 0.25 millimeters, and the number 2 bearing was slightly rubbed. After the straightening treatment, the shaft straightening treatment, the unit started up and connected to the grid normally, and operate at the full load smoothly. Hi everyone. We think that's all for this morning's training content. So we will continue this afternoon.
Okay. You can continue.
Thank you. Thank you.
Thank you.
See you this afternoon. Bye.